Hello, everyone. Good afternoon. This is Madhav Dhakal from Rodale Institute. For next 50 to 60 minutes, I'll be talking about growing industrial hemp as a multi-purpose crop in organic cropping systems. Let's talk about hemp in general. The scientific name is Cannabis sativa. Subspecies is sativa, and there is another species which is indica. I didn't mention the ruderalis, that's the third species, but these two are the typical cannabis species grown in the world. So Linnaeus described sativa as the fiber type species for the hemp, and hemp has both industrial and medicinal uses, and the first use was recorded for like a 50,000 years ago. It was spun into usable fiber, whereas the morphology of the hemp is this is annual, normally dioecious, like the male and female plants are separate. So it grows from 20 centimeter to 6 meter tall, stems are erect, hollow. This is tap-rooted crop. You can see the leaf pattern, which is palmate. Terpenoids and cannabinoids, these chemicals are biosynthesized in inflorescence, and the crop is photoperiod sensitive, usually short day. And this is a C3 plant with high carbon dioxide response and is water efficient. And this is just the short morphological feature of this crop. So if we talk about the typical cannabis type in terms of chemical properties, these are three chemotype. For example, chemotype 1, 2, and 3, which are based on the THC and CBD profiling of the ratio. Chem 1 is like a high THC content cannabis or the hemp species, and the low CBD type, where the chem 2 has more THC and more CBD. The ratio of THC and CBD is equal to 1, nearly equal to 1, whereas the chem third type hemp has low THC and high CBD. So these are the three chemical categories of the hemp species. Usually when we refer to cannabis indica, which is the narrow leaf drug or the wide leaflet drug biotype, we call it cannabis. But if we pronounce as a hemp, then we are talking about cannabis sativa. So throughout this presentation, if I'm talking about hemp or if I'm pronouncing hemp, I'm talking about cannabis sativa species, not the indica species. So let's talk about the hemp origin and history. So the first record of the hemp use, which was recorded from China, according to USDA-ER's publication, and it was brought to Europe in 16th century for seed and fiber. Then at the same time, it was also recorded in Chile, which was brought to, at that time, New England. And the cultivation spread to Virginia and some Midwestern states of the US as well. So basically, during 1840s to 60s, it was used for sailcloth, basically in the US Navy. So there is still legal battle regarding the hemp production in the US. There are several states, technically 11 states, that permit to grow hemp, whereas the other states, some states use it, allow both type of cannabis species, while some states they just allow for the research. And basically, the hemp, growing hemp is illegal in some of the states. So this is under debate in the US. So actually what happened was after 1937, after the Marijuana Tax Act, it was banned all over the country, like all type of hemp. And after World War II, almost it was completely disappeared from the country around like 1950s or 55. And on the Controlled Substance Act in 1970, cannabis was classified as a Schedule I substance plant, and that means it was both the hemp type, like the cannabis type, and the industrial hemp, both were restricted by that act. But later in 2014 and 18, US Farm Bill recognized the importance of hemp, like the low THC content hemp, as a potential commercial crop. So basically, after 18, Hemp Farming Act removed industrial hemp from Schedule 1 controlled substance. That means now it's getting popularity, and also states are favoring hemp production in the country legally. So there may be something coming up, like in terms of pesticides labeling, and more research we can see in the future as well. So when we talk about the importance of multi-purpose use of hemp, or the importance of hemp, almost every single part of the plant can be used. For example, stalk, where we extract fiber, and then the heart as well. The fiber can go to textile for clothing, shoes, handbags, and diapers. Whereas the general use of the heart is like for the construction, paper, cat litter, potting mix, compost, hydroponic filler, animal bedding, mulching, hemp crate production, fiberboard production. These are some of the uses of heart. The general use of the hemp biomass or the stalk is like paper production, producing mat, rope, insulation materials, and the reinforcement. And the seed can be used to extract oil for cooking, shampoo, soaps, lotions, solvents, for the paint, varnishes, and fuel. And the kernel can be used for edible flour, beer, animal feed, bakery, and milk. Where the leaf, specifically the nitrogen-rich leaves, which can be used for compost and mulching and animal bedding as well. Besides, hemp is a tap-rooted crop, so it can sequester carbon and aid soil organic matter to the soil, which has overall implications of improving soil health. Let's talk about the climate and soil requirement for the hemp, which is this crop is adapted to well-drained soil with pH between 6 to 7, so which is almost like a neutral soil type required for the hemp production. Basically, soil moisture is also critical for efficient decodification, even though hemp can tolerate certain level of moisture stress, but make sure that you are not giving much stress, because decodification is the process that you separate the fiber from the heart or the woody core, and that can be difficult if the moisture is low in the soil. Soil nitrogen is also critical. It has a major role in fiber production and fiber quality. So, and it depends on what type of hemp you are growing, whether it is seed hemp or fiber hemp. Based on that, the amount of nitrogen removal from the soil is around 100 to 150 kilogram nitrogen, 40-50 kilogram phosphorus, and then 50 to 70 kilogram potash. And the data is really variable. I mean, I saw like the potassium use of hemp is one thing which is noticeable here, because which is related to the flowering and then also the fiber production. Calcium and sulfur are the two macroelements which are also very important for the hemp growth. And it prefers mild climate, subtropical. We can see some other cannabis species in like in tropical environment, but usually in mild subtropical temperature with the rainfall. At least I would say we can see like a 25 to 30 inch per year is okay for hemp production. So mostly in the US, like in this area and in the Midwest, it can be supported. It needs temperature more than 45 degree. Oh no, this should be like the Fahrenheit, not Celsius. So that's the mistake there. More than 45 degree Fahrenheit for germination and more than 65 degree Fahrenheit for growth. This is heliophilic crop. That means it loves sunlight. Make sure that it's getting more than 6 hours of direct sunlight. And so when we talk about the varieties or the type of hemp, so basically the industrial hemps are two types. One is grown for fiber, another is grown for seed. So there are hundreds of cultivars under these broad categories. So I'm not going to list, I'm not going to give any preference towards any specific cultivars. These are just some example cultivar under that hemp type. So the fiber type hemp, which is desired for the thick stalk and which is very slender, grow really taller, and then have low number of branches as compared to short growing thin stalk seed type hemp, which has numerous branches and produce inflorescence in those branches. And then fiber hemp also produce more biomass and also have small seed head as compared to the low biomass and larger seed head of the seed type hemp. Usually the fiber hemp varieties are shorter duration, whereas the seed hemp varieties are longer duration varieties. Shorter duration means 45 to 70 days is the fiber will be ready to harvest, whereas the 100 to 120 days is required for the hemp seed to mature and harvest. So here's the example. The photograph shows two different hemp. On the right hand side, here is the Santika 27, which is really tall and thick. Whereas the right hand side is the Arlena, which is the seed type hemp, which is short and also thin in terms of the stalk size. Planting hemp. So basically, in our environment here in Northeast America, US, the planting time would vary from mid-May to mid-June for the fiber hemp, which is early May to early June for seed hemp. So we planted here in last week of May or in first week of June last year. So the planting method would be different. It depends on what type of soil is there, like whether you are planting no-till or with the tillage. Basically, hemp prefer, because this has a small seed, so you may be like preparing a soil like this conventionally. The ideal condition is like a well-prepared fine soil where you plant your hemp with the drill or the planter. But I'm talking about the organic production of hemp, so we are not. And in the regenerative system, maybe you are interested in producing hemp after the cover crop or with the cover crop residue on the top. So that means you need to make sure that the residue is low on the top, or you are properly terminating your cover crop, or like rolling the cover crop or mowing it and making the seeding row really clean because that is needed to allow proper emergence of the hemp after planting. The fiber hemp, and for the planting, of course, because it's very difficult to find, or maybe impossible to find the specific planter for the hemp, like the hemp specific planter, but sorghum planter or the sorghum setting in your drill or planter would be okay to plant hemp. If you are trying first time conventionally, make sure that your soil, you are doing tilling with the chisel or moldboard plow, and then go with the discs 1 or 2 times, and then pack your soil and then plant. Seeding rate is for the fiber hemp, like it's 25 to 35 pounds per acre, and then for seed hemp is 50 to 75 pounds. For the Santika should be like fiber hemp. Fiber hemp is like 50 to 75 pounds, where the seed hemp is 25 to 35 pounds per acre. The plant spacing, it depends. You can go with the narrow spacing or the wide spacing. We planted with 7.5 inches row spacing. It was perfectly fine. With that spacing, hemp was doing well with conventional tillage system. Here's the no-tillage. Planting was not 100% successful when we tried because of the residue on the top. In this picture, you can see like the stand density plants per square meter area with 2 systems. CT is the conventional tillage, NT is the no-tillage. You can see with no-tillage, there are like two conditions: CC, cover crop, NC, no cover crop. The yellow is no cover crop, blue is the cover crop. So looking at the conventional tillage side over here, the stand density under the conventional tillage, both cover crop and no cover crop, the stand density is fine, which is between 75 or 80 to 110 or 115 plants per meter square, which is about 375,000 plants per acre for seed hemp density. For no-till hemp, the density is really, really low, which is about 10, 15 to 20 plants per meter square. And with cover crop on the top, like vetch and Austrian pea was the cover crop, the emergence was really poor. And it was like a 74% lower as compared to the conventional till for the seed hemp density. For the fiber hemp, the emergence was better, even better under the conventional tillage practice. Like we tilled for the termination of cover crop, like with the cover crop, the emergence was good. The stand density was really poor under the no-till system, especially with the cover crop residue on the top. So both fiber hemp and seed hemp, the establishment was poor with the no-till system. And it's not only because of the cover crop residue on the top, maybe the planter setting, or because we didn't know much about the hemp establishment, and there could be many factors confounding on the emergence and then establishment of the plant. Well, the germination was okay with the no-till system, but just the emergence was not great. Let's talk about the fertilizer management. The amount of fertilizer depends on the soil fertility status as well, and then your cropping history, whether you are growing cover crop in the system or not. If you are, if the hemp is followed by hemp is following the cover crop. If you are planting hemp after the cover crop termination, maybe your nitrogen requirement would be low, but you need to keep in mind, like, if you plant your hemp in early June, your exponential growth of the hemp will occur after second week of July until the first week of August. That means this is the critical time that the plant accumulate nitrogen and also like grow exponentially. That means the nitrogen requirement would be critical by that time. What we saw is a fiber hemp produce more biomass as well, and the nitrogen requirement is higher for fiber hemp as compared to the seed hemp, which is about 100 to 150 kilogram per nitrogen. It depends, but it depends on the cover crop and then the fertility status. I'll be showing the nitrogen response to the hemp biomass production. For the seed hemp, the nitrogen requirement can be low. And then phosphorus and potassium are also important during flowering and seed formation, especially for the seed hemp type. And from our experiment at Rodale, we found that hemp can remove up to 102 kilogram nitrogen per hectare from soil, which is and with 11.5, almost 12 kilogram nitrogen per hectare in the grain. So in Canada, I saw the literature, like it was reported up to 202 kilogram nitrogen removal per hectare. So yeah, this is the this number we found. And then the rapid growth, which occurs in the last 3 weeks of July in the Northeast region. Maybe in your region, the growth pattern would be different, which accounts for almost like a 50% nitrogen within 3 weeks. So cover crops in organic systems, basically the cover crops and the organic fertilizers, like we supplemented with the blood meal, so you can use the compost and other organic fertilizer sources as a source of nitrogen and other like the elements. So basically, from one trial, we were kind of looking into how does the cover crop and tillage impact the nitrogen availability to hemp and barley in a crop rotation. So we rotated hemp with barley as well to see how the nitrogen can impact, or the supplemental fertilization can impact the nitrogen availability. And then also we are investigating if the hemp needs supplemental nitrogen to optimize yield and quality of the barley, and does cover crop tillage and nitrogen fertilization affect fiber, seed yield, and its quality. So, and then we planted cover crop. The biomass of the cover crop was almost like 5 tons per hectare, which was close to 140 kilogram nitrogen per hectare, or the 125 pounds nitrogen per acre. And we terminated cover crop with, at the time of 50% flowering. We rolled and creamed the cover crop by using the roller, INJ roller crimper. At that time, for the no-till planting, for the till planting uses, we mowed it and then tilled the plots. Here's the seed hemp biomass. This is the hemp biomass, like ton per hectare for seed hemp type. So these are the 4 figures I'm showing here. So the first one is for the conventional tillage cover crop. So it was followed by cover crop. Hemp was followed by cover crop under the conventional tillage system. The second one, hemp was followed. Hemp followed the no cover crop. There was no cover crop before hemp, but it was tilled before hemp planting. The other 2, no tillage with cover crop, the third one, and the last is no cover crop, like completely weedy plots. So the 3 color, these are the yellow color is for stem biomass, gray color is for leaf biomass, and the blue color is for the flower, inflorescence biomass. So, and then the x-axis shows the nitrogen level, 0, 50, 100, and 150 kilogram nitrogen per hectare. We applied this nitrogen in the form of blood meal. That's the 13% nitrogen in that meal. So we calculated and applied like a 50, 100, and 150 kilogram nitrogen per hectare. So let's talk about the biomass response with that fertilizer application. So we found that if there was cover crop in the system under conventional tillage, actually there was no significant differences among treatments. Like there was no effect of fertilizer application. There was no point applying more fertilizer, adding external fertilizer if there is cover crop in the system. That means cover crop can supplement the required nitrogen for the seed hemp biomass. For the no cover crop system, I would say there was a linear trend, like adding more nitrogen was actually putting more biomass up to 100. So after 100, there's no benefit. So 100 kilogram per hectare was ideal, or was optimum. However, it was equal to the 50 as well. The similar letter means they're statistically same. Lower 2, these 2 are similar, these 3 are similar. So I would say, like, I would recommend going up to 100, or maybe stay between 50 to 100 is okay without the cover crop. For no-till, there was no response because the establishment was poor, and then the nitrogen was only like enhancing or exacerbating the problem of weed, because weeds were taking advantage of the nitrogen application, not the hemp. But in the no cover plot, you can see the biomass production was almost completely gone. The plants were like just 6 to 7 inch tall as compared to 6-7 feet taller plant in conventional tillage system. Here's the fiber hemp biomass. The trend is almost the same as the seed hemp, but it's a little bit different than the seed hemp for the cover crop based conventional tillage system. Here, with cover crop, 100 kilogram nitrogen per hectare did well, but other like there was 100 was more than 0 and 50, but after 100, the yield was, the biomass production of the fiber hemp was low. That means with cover crop, if we add more nitrogen, maybe it could be antagonistic to the hemp biomass production. But without cover crop in the system, the fiber hemp biomass can be improved with nitrogen application. So after 100 kilogram per hectare, there is no such improvement. Statistically, these 2 are same. So I would say like 100 is ideal for the fiber hemp biomass production as well. The no-till, even though it wasn't affected by nitrogen, especially for the cover crop based no-till, I would say the more nitrogen was numerically having the highest amount of nitrogen seems producing more biomass, but overall, no-till didn't do well. And we really don't know whether the applied fertilizer went to the weed, partition to weed, or actually if the hemp benefited from the applied organic fertilizer. So if we look at the linear trend of hemp leaf biomass and then the fertilizer label, it was linearly correlated. There was a positive linear relationship between the increasing fertilizer application with the leaf biomass production. The same thing for the seed material versus nitrogen label. So increasing fertilizer amount increased the seed mass or the seed production of the hemp when we combine the data from the seed and fiber hemp type. So weed management. Weed management is critical before we establish the plant, because the hemp seedlings are not very competitive if they are very small. So field must be, I would say, weed-free before planting or during early emergence. That's why I suspect, like the first picture showed, this is the no-till plot, and you can see a lot of weed on the surface, even with the cover crop, and that means the establishment was really poor. We tried to control the weed with mowing it. You can see the picture with the mowing. So especially this in summer, weeds can be problematic within a week after you mow it. So flame weeding, we did it, but it didn't help much. So for no-till organic planting, mowing, flame weeding can be done if the weed size is small, but if they are very big, then maybe it could be problematic to establish the hemp in no-till system. We should be careful about not having weed pressure, especially during the early establishment phase. 1 month after planting, we found that from our experiments, it's okay for hemp. Like they can literally shed all the weed component, and then they effectively suppress all type of weed, mostly broadleaves. You can see the soil surface in this picture. It's very weed free. So that means it's not only about controlling the weed during the hemp season, but you are also depleting the weed seed bank for the next cropping season. And that means the crop that follow the hemp will be benefited, can be benefited from the depleted or the reduced seed bank because of the hemp. So to get that weed suppressive effect, narrow spacing is recommended. So we planted at 7.5 inch spacing, and that almost like completely suppressed the weed. For wide spacing, if you are planting your hemp with like a 30-inch spacing, I would say inter-row weeding or the inter-row weed control is critical because that means the canopy closure would be late until your 30-inch spacing would be covered. That means you need some sort of weed control, especially in the first month. So weed biomass, this is the same thing that I would like to repeat. Here's the weed biomass on the y-axis and the fertilizer label on the x-axis. You can see the biomass of the broadleaf weed, grass, and sage. So the broadleaf weed biomass is on the purple color, and then the grass is green and yellowish sages. So almost all type of weeds were controlled or effectively suppressed, no matter how much fertilizer, nitrogen application you did. But under the conventional tillage system, because the hemp biomass was really high, weeds were effectively suppressed as compared to the no-till. So if your hemp stand density is lower or poor, weeds can be problematic. So make sure that you are planting your hemp with the right amount of seed, like proper seeding rate, so you will get, especially in the organic system, because there are no herbicides allowed. That means the system itself needs to suppress the weed. That means you need to maintain the stand density, make sure that you are properly establishing the crop, So we can see no matter it was the cover crop based or no cover crop based, especially with the cover crop system here under conventional tillage system, weeds were effectively suppressed as compared to the no-till systems, especially with the no cover crop in no-till, because there was no benefit of having cover crop residue suppression in no-till, no cover. That's why the weed problem was the highest as compared to other pre-cropping systems. So when we look into the relationship between the broadleaf biomass, broadleaf wheat biomass, and then the hemp biomass, we can see the relationship, like a very significant relationship with high Irish core value. And we can see like increase in hemp biomass exponentially decreased broadleaf wheat biomass. That means the same thing I would like to repeat. We should maintain the hemp population so it produces more hemp biomass or the more leaf mass to save the weed. So especially the broadleaf weeds can be controlled with the hemp production. So the same thing like the opposite, this is for the conventional system. For the no-till system, the high weed biomass actually reduced the hemp emergence and then also the hemp biomass here. The hemp biomass was severely reduced by the wheat biomass. So it's like a two-way relationship between how the weed can respond to the hemp biomass or the hemp stand density, or how the weeds, if they are dominant there, can impact your overall hemp biomass production. So these two-way relationships, these are significant, and also so that there is a direct or very like a close relationship between the weed and then weed growth and then the hemp growth as well. Similarly, weeds are not only the problem in hemp. When we are going for the commercial production of hemp, of course, there are many other factors that we need to deal with. So insect and diseases, these are some of the other things. So these are some photographs that I adopted from Krantz et al. It was from the publications of his team, and we can see different type of borers, beetles, this Japanese beetle, and sometimes we can see the plants were lost because of the grasshopper feeding here, and the stinky bugs, caterpillars like a corn, yarrow, and then aphids. These can be, you can see a different type of pest on your plant, damaging different parts of the plant, such as leaf, inflorescence, and then the stalk. So, but unfortunately, there are no pesticides which are specifically, typically labeled for industrial hemp production in the US due to conflicting policies and federal regulatory actions. But however, in organic system, we are not allowed to use these synthetic chemicals. So crop rotation, planting volunteer crop, these are some of the ways that we can prevent pest. And of course, the organic hemp production is inevitable, and no matter if the pesticides are available or not, we can always use the neem oil as a leaf sign product or the soap detergent as a plant wash to control these type of pests. Harvesting is the another aspect. Like for the seed hemp, the harvest would be different, and for the fiber hemp, that could be different. Grains should be harvested. If it's seed hemp, the grains should be harvested when 80% shoots mature. Moisture content should be near about like 15%. You can use grain sorghum setting to harvest the upper part of the plant. It depends on how tall is your crop, but you can always adjust your setting. The seed hemp types are usually shorter than the fiber hemp types, so I can assume like your harvester can handle harvesting the seed. Use the right setting for the cylinder and the auger speed. Otherwise, it could be detrimental to your equipment if you don't use the proper setting on your harvester. So drying of seeds should be dry. You should set the temperature around 140 degree Fahrenheit or the 60 degrees Celsius. Hemp grain contains, alpha-linolenic acid, omega-3 fatty acid. which is about 30-35%. But some oilseed crop, they contain up to 60-70%. But this is good. And fiber hemp, you should harvest your fiber hemp when the seed set or reach about like 30% early blooming stage, and use single or double sickle barm, or if needed, triple, to cut the stalk and allow dew rating for 2 to 3 weeks. Rain is fine. You just need to monitor the moisture content in rated hemp mass, and make square and round bales. I would say round bales are preferred for decodicator machine if you are taking to the decodicator, and the moisture of around like 15% is ideal. These are the square bales. Those were around 2,000 pounds in our facility, but I would say the round bales are about the same size. They can be around 200 to 1,500 pounds. And the bast fiber, which is the bark, that range about like 10-20%. But that's the high number. I would say from the green material, this 10 to 20% is from the rated samples, but from the green material, that's around 3 to 4%. If you are looking into how much bast fiber is there in your crop. Thick stems are desirable for the high fiber yield. Rating is the microbial process that breaks the chemical bond that hold the stem together, that's the woody core together, and allows the separation of the bast fibers from the woody core. Traditionally, rating can be done by using field rating. We call it the dew rating and the water rating. Usually the field rating are the one the growers are using here. Water rating is not, we can see here in the US, but in some Asian countries, we can still see rating of hemp by using the fresh water. Dew rating, for this, stems are cut and pulled and then left in the field, like in the picture. You can see this is the picture from our site, and you allow to decompose for like 2-3 weeks, but you need to continue monitoring and ensure that the bast fiber separates from the heart. You can go and check and make sure that it's really coming separating from the woody material, and wait until it dries out for baling. Not completely dry, but around 15% moisture. Dew rating is inexpensive and is really easy. Maybe like in no-till setting, if there is residue and grass and weeds, you have to be careful about. I had a phone call with a farmer today. He also suggested me like we have to be careful about not using the conventional, the traditional raking, but it can be done with a proper baler if we want. Water rating is not popular here, which is expensive and labor intensive on the process produced, but it produced a high quality fiber with more uniformity, and the stems are immersed in water for like several weeks, which are still popular in China, India, and Hungary. And the fiber separation is the different process. After rating, we separate the fiber. When properly rated stalks pass through 2 fluted rollers, this is the traditional like a fiber separation thing. That means scotching is the process, like you pass the rated stalks through 2 rollers, and then it breaks the heart. Then the bark or the bast fiber can be separated out. The equipment, nowadays we can see the single large equipment that can separate the fiber and heart, which is called decodicator machine. And then let's talk about the hemp seed yield. So based on the hemp type, the seed yield can be different. From our experiment, by testing 2 hemp type, fiber and seed, we found the seed yield was around 500-600 kilogram per hectare from both seed and fiber hemp. Fiber hemp was even producing numerically more seed as compared to the seed hemp. So the seed yield was also different between conventional and no-till. Conventional, of course, the hemp establishment was good and was producing more seed as compared to no-till. I would say some varieties or cultivars can be dual type, so you can make an advantage of like having seed and fiber, but be careful about the fiber quality, because some fiber type hemp, they produce the good quality fiber, even though some seed type hemp they produce some fiber, but the fiber quality may not be good. So the dual type hemp means you should consider the quality of fiber as well. So this is the data from the US DMSA, and it says if there is like a 40,000 kilogram per hectare green hemp biomass, you are getting 3.5% of the dry line fiber. So this is the process through which it goes. And this slide I'm showing is how much fiber you get from that hemp. So this is all you get, like it's only about 3.5% of your green biomass for the fiber hemp. So the hemp processing is getting into mainstream. There are more and more facilities opening up in different states. This is from the South Dakota, Winfred, South Dakota, and this is a new decodification facility. You can see the huge machine. These are the round bells. You can feed it into the machine and it separates the hardened fiber, like in the picture here. And by this process, it depends on how big is your plant. It can process like 1 ton per hour or 5 ton per hour. And collection up to like 120, 150 miles is economically feasible to operate the business. And here is the owner, plant manager for the South Dakota facility. And this information I got from Ken. He's the president of the association, Hemp Growers Association. And there is another processing facility in Pennsylvania, which is Dawn Processing. Lori Detnercy, this is the VP of Program Development there. And there is no premium, because this is in the early phase, so there's no premium price set up for the organic fiber. But however, maybe in the future, so the organic pricing would be different from the inorganic for the hemp, but there is a premium price for the seed for the hemp. So price is relatively constant if you look into the hemp fiber or the hemp seed pricing in the US, at least. So economics, I look at the Penn State Extension, and then also consulted the South Dakota Growers Association. Ken was here. We talk about how much economic returns that the growers can get from Penn State Extension publication. Is not really high, especially for the fiber hemp. The return over variable cost is okay, but the return over total cost, it's just 74 per acre, US dollar per acre. For seed hemp is really good. But according to my conversation with the president of the association, $300, you can see the price here, $300 per ton. This Penn State data is based on the $100 per ton, but putting $300 there, and with the production that we got, like a 5 to 10 ton per hectare here at Pennsylvania. So I calculated based on that. I found within the parentheses, it's like $1,200 per acre for over variable cost, almost like $1,000 per acre for over the total cost. So the economics is really variable, but I would say it depends on the market capability and your like the quality of the fiber as well. So crop rotation is another thing that the benefit we can get from having hemp in the system, or the diversification, because it breaks the weed life cycle and depletes seed bank, as I mentioned, and also changes the soil environment for weeds. Also alter the stress and mortality factors, because some hemp can also provide the allelopathic chemical to the soil. That means it can effectively reduce the seed bank or weed seed bank. Changes the weed community assembly, and that's important. And it also builds healthy soil, add a lot of carbon and sequestrate carbon. It can add tremendous amount of organic matter to the soil. That means we can build the soil health by using hemp in the crop rotation. And the diversification has numerous benefits. There are so many publications in really good journals with several studies showed that it can, crop diversification effect on wheat density was stronger for the reduced tillage system than the tillage system, and the diversification can actually improve the yield in the rotation. That's why we tried barley, like the small grain, in our experiment as well. So with 25 to 35 inches annual rainfall, small grains can be planted after hemp without having soil moisture issues, such as wheat, oat, barley, buckwheat, triticale can follow hemp. So double cropping is possible with hemp. If we plant like lettuce, spinach, collard, kale, mustard, radish, carrots, then we can have 2 crops in a year, and that's even better than having soybean and corn in the crop production system. So put legumes before hemp for the best results. For example, clovers, cover crops, and then soybean and alfalfa are better for the hemp production if you are planting your hemp after those leguminous crops. And hemp is also excellent green manure for wheat. And you can see the picture here. This is barley, malt barley. We planted after hemp, and there's really very low wheat pressure. And if we see the crop, this looks so healthy, so luscious, and it's even better than the conventional crops. So what we did was, like, we rotated the hemp and barley with cover crop in the middle during the winter. So the barley is actually the malt barley. So what we're looking at is we're looking into cover crop, how much nitrogen it can add, how much soil organic matter it can produce, and how much soil health it can improve. So we are looking into nitrogen adjustment by hemp, how much weed it can suppress, another benefit is like hemp. We harvest the hemp in August, means there is enough planting window for the fall crop as well. And because hemp actually utilizes more nitrogen, so that could be optimum for malt barley production, because the nitrogen requirement is low for the malting type barley. You need 9 to 12% crude protein, not more than that. So hemp can modify the nitrogen content in the soil. That means barley can be benefited after hemp, and the cover crop add nitrogen for the hemp. So this type of cycle can be beneficial to build the soil health and for the overall crop production. So you don't need the supplemental nitrogen with the cover crop, and the hemp reduce the nitrogen use efficiency for the malt barley to produce the best quality, best malting quality. So other environmental benefits are like a sustainable agriculture, because we're talking about the organic hemp production, that it improves the soil health when incorporating in the cropping system. So we are literally essentially reducing the herbicide use by lowering the wheat seed bank by using hemp, and it increased the carbon sequestration with elevated temperature as well. Shorten the carbon cycle, because hemp biomass production occurs within like a few weeks, means the carbon cycle can be shortened. And it conserves the forest by providing material that can be used to build residential homes, papers, fabric. Especially it can reduce the emission, like dioxin emission that comes from the paper mills. By using hemp, some of the toxic chemicals can be mitigated. And then it provides healthy insulation options for construction. The bio-based fibers can help to reduce the use of plastic materials, reduce the need for intensive irrigation, and helps to save the water, because the water use efficiency of hemp is much, much higher than some other row crops that we grow here in the US. So major takeaways: industrial hemp can be produced organically, not under the no-till, but with the conventional tillage. Well, organically it can be managed really well without any weed issues or the weed problem. And both fiber seed hemp may not be suitable, but it's not conformed result. We're going to try it with a different planter setting. So I'm hoping that we will make it happen for the no-till production system as well. Stand establishment is highly dependent on early weed pressure because hemp seedlings are not tolerable to any type of weed pressure. These are not corn and soybean. These are not like other row crops. Hemp seedlings, they are very vulnerable, especially for the first 2 to 3 weeks. And the biomass and seed yield can be boosted with supplemental nitrogen if cover crops are not present. If there is cover crop, you don't need to worry about adding nitrogen fertilizer. And hemp can effectively suppress weeds. So at the end, I would like to give our contact. Here's a website, www.rodaleinstitute.org. If you want to have this recorded webinar at some point in the future. So there's my phone number and my email address. You can see on our website as well. Please contact our education department, our Dean of Education, Director of Education, and Global Education Manager for having any questions or to access the recorded webinar. And I would like to acknowledge the resources provided by Rodale Institute and the USDA and RCS for the project results. And thanks to all research technicians and interns working for the project as well. And thanks so much. I would like to take your questions. So as I mentioned, like I'm going to answer the questions from the Q&A section. So what about chemotype 4 and 5? Can you please talk a bit about the other chemotypes of cannabis sativa L? Of course, basically there are still like some debate of having how to categorize the all cannabis species. There are 4 and 5 categories, but broadly that's what I was talking about based on the THC and CBD ratios. But for this industrial hemp production topic, we are not actually dealing with any hemp types which has 0.3%, more than 0.3% THC level. So we are not worrying about that. And I think like chemotype 4 and 5, I don't know much about that. But like the hemp that we are growing is a sativa type, and of course like having a very low amount of THC content in it. So if I find anything new about the other chemotype hemp, then I would be happy to talk about that. Can you please talk more on how soil moisture plays a role? Yes, the soil moisture should be enough to, like, if the moisture stress is high, especially at the harvest period or the harvest time, then the decortication can be very, very difficult because the bast fiber may not separate easily from the woody core. It's just attached there, and the reading process, it needs moisture, microbial decomposition, and the microbial population needs water molecules for the proper decomposition of the materials to separate the bast fiber from the woody material. So the moisture is important, and you don't need a very high moisture, but the soil should be like a moist, not very dry. Like in the semi-arid region, the soil can be very dry, and that could be problematic for the decortication. And what type of hemp production are you referring for the optimal soil nitrogen? There are probably studies showing that the less soil nitrogen increases secondary metabolites of interest. Well, there are publications like they show the relationship between the nitrogen and then the secondary metabolites. But here I'm talking about the like a fiber production perspective and then the seed production. What we found was like by looking into the other experiments as well, it varied very well, but 100 to 150 kilogram nitrogen per hectare without the cover crop was the nitrogen rate that we found suitable for the fiber and seed hemp production. But for the other hemp type, like the CBD or the indica type, there should be some specific role of nitrogen for the production of secondary metabolites, which are the interest for the CBD type hemp production, but not for the industrial hemp production. So specifically today, I saw like a questions about the chemotype, other chemotype hemp, but this presentation was entirely based on the industrial hemp. So we are not talking about the secondary metabolites like a CBD or THC or other metabolites produced by the cannabis, other like cannabis indica type. So I think we will have another webinar from our other scientists from the another station about the different type of hemp that you are asking about. But yeah. But definitely today we talk a lot about the fiber and seed hemp. Plant spacing, we use the same plant spacing 7.5, but the plant spacing should be different for the fiber and seed hemp. It can be different, but we don't have the definitive result how much plant spacing and the plant to plant spacing or the row spacing is better to produce the optimal thickness of the like a fiber hemp and then the seed hemp. So more research is needed to find out to calibrate, to fine tune the plant row spacing and then the plant to plant spacing, I believe. But we thought like a 7.5 to 15-inch spacing is okay to produce the fiber and seed. I believe like for the seed hemp, the seed rate can be reduced a little bit more because the plants could be, because they are more branch type. Means we need to be careful about spacing them. I believe with proper fine-tuning, the plant spacing would be different for those two type of hemps. Who's developing a hemp cultivars that use high volumes of grain as well as high volume stock. Such cultivars could be used to some meat while also generating lots of how deep you are planting both fiber and seed hemp. Okay, so our goal for the no-till was to put the seed at like 0.5 to 1 inch depth. But for the conventional tillage, for the till plot, 1 to 1.5 inch is okay, is ideal because the seed size is small for the no-till. Of course, I mean cutting residue and then putting seed would be different. So, 1 inch was the target for the seeding depth. And oh, there are so many questions. I would say please. I can't answer all of them because we are over 1 hour. If you have any questions, please have them in our email, and I will try to answer them if you email me, because I can see there are some questions about the fiber varieties. Male plants a given variety produce more best fiber. Yeah, there are many questions that I would say the research is ongoing. We have a few things to share, but there are many things that we don't know, and then we still need to explore more regarding the hemp production. And of course, in the future, we'll have more and more information about the allelopathic chemical that you have questions about, and then also the breeding and the mixture with other, like how it does with the companion crops and how we can prevent the caterpillars in the season. So yes, and there's one thing about like showing the more takeaways. Thanks so much for your time. If you have any more questions, please email me, or we have, you can go to the website and there's phone number. And also have the contact us section to contact for the questions. So thank you for your time, and thanks for joining this webinar.